Hello. Yeah, I'm gonna be talking about how you can use AI in a very nice use case to automate production fixes using open source tools and AI models. And so hopefully you'll get an idea. I'm gonna do the demo so you can see how you can do it today with all open source. I am Carlos. I am a principal scientist at Adobe Experience Manager. This is a content management system, and I've been contributing for a long time to open source, and people made me feel very old this weekend. There's a lot of young kids here. I'm also part of the Google Developer Experts program. So before we start, who's here heard about Argo in general? Okay, Argo Rollouts? Some people. Okay. Well, I'm not going to ask about Kubernetes. And who is doing canary deployments or some sort of that? Okay, just a few people. And who believes AI is going to make our lives easier? Okay. Who believes AI is a fad and this is going to die soon? Okay. I think you're going to be in trouble. But that's my opinion, but we'll see. So, progressive delivery, you have probably heard this term today or before, and this is just a name to groups all these deployment strategies that try to do progressive changes to your production or whatever, so you don't break everything at once. So new versions get deployed, but they don't replace the existing versions. It just goes progressively changing your infrastructure, your application, something like that. And then the interesting thing here is that you are evaluating this live production traffic, so you don't have you don't rely on unit tests, integration tests, but you rely on actual production data to decide whether your rollout is being successful or not. I'm old enough to remember when CrowdStrike took down half of the internet. We're at FOSDEM, so it is only affected people with Windows, so we don't care, right? So one of the interesting things, and I recommend everybody to read the root cause analysis of all these big outages like Amazon, Microsoft, whatever. It's very interesting. I think it was here, yes. It says, now the new model, because they deploy something, it broke everybody at once, and the new model is we're going to do rings, and every ring is going to be deployed, and then we're going to check if those rings are going fine, and so on. So basically, they're going to switch to a canary deployment of some configuration scripts that before they were doing just all at once. So people are getting a lot of interest on this because they realize that otherwise they're breaking the internet. I'm going to skip the slides, actually, because you already know all this stuff. And I'm going to go directly to Argo Rollouts. Argo Rollouts provides these advanced deployment techniques, and it makes it really easy to use them on Kubernetes. So you can do blue-green, canary analysis, experimentation. Experimentation, if you haven't heard of it, is very cool that you can say, okay, I want to run this for 2 hours, 5 hours in parallel, and then I can see if this works or doesn't work, and then I can kill it afterwards. Like things like we use it for, or we're looking at using it for Java upgrades. Okay, we want to run 2 pods or 10 pods in production and 1 pod in experimentation. We're saying, okay, let's run this with Java 21, 25 and see if it works. And we just need to run it for a few hours to make sure, and then look at the logs and see if there was any issues there. The way Argo Rollouts works, you have the rollout controller, and you have some objects in Kubernetes. The way you get traffic is through the ingress as usual with Kubernetes and the service, and you're going to have 2 replica sets on Kubernetes. One is the stable, whatever you're running today. One is the canary, it's basically your new version of the image or configuration, and then the analysis run object is an instantiation of the analysis template. The analysis template is what says what a good analysis is, what a good canary is. If the typical case is go to Prometheus, get this metric, if 500 errors is over 5% or 1% or whatever, it's a bad canary. So the analysis run checks that, and that's gonna decide whether the canary keeps moving forward or the canary is rolled back. And here in the analysis template, you can decide, I want to do it 1%, then 5%, then 20%, whatever sort of analysis you want to do. You define it on the analysis template. And you have a bunch of plugins, metrics plugins, the Prometheus. You can run just a Kubernetes job that will decide whether your canary is good or bad. And the one I added here is one to do it with AI analysis, with an LLM. So we are now going, the demo I'm going to show you is you have the source code, you deploy it, you do the canary analysis. Now an LLM is going to decide whether this canary is good, and then it's going to promote it as usual, or if it's bad, and then it's going to roll it back. So Argo talks to this plugin, and this plugin will do, this is an agent using A2A, that will look at your Kubernetes with whatever tools you want to create. I have an example agent that does the list pods, get logs, get metrics, get events in Kubernetes, and so on. And that gets thrown into the LLM, and the LLM will tell you exactly what the problem is. Trust me. Now, bear with me for a second, because what happens after this? I don't want to have to go and look at what the problem is. What I'm doing is my plugin will do, besides the rollback of the canary, it will create a GitHub issue. It will assign an agent, an AI coding agent, that it will generate my pull request, a pull request for me, that I can only have to approve, and then I go back. Or I can just say, this would take a bit more work, but you could say automatically merge it. And then you get the full loop, absolutely automated. And this works fine 100% of the time. So, yeah, that's what we're going to end doing. So we have Argo here running. I put this on the top because probably otherwise on the back you're not going to see it. Okay, so I have my green, my application is showing green, it's responding with green color. All right. If I only have one pod here for the sake of the demo to not bother too much, but if I say blue, if I do an upgrade to blue, I'm running a new canary with a new pod that is gonna be blue. And here we should be, soon enough, we'll see some blue dots, which means the traffic is going to my new version. So, and the canary is going to do the analysis, and is going to decide whether this new blue implementation is going to be fine or not. And let's see why it's not getting anything yet. The analysis is running here, so we should be getting some blue. Why is not getting some blue? Obviously, always the demos are not working. It is blue. Am I running the right one? Okay. Something is wrong because I'm not getting any blue here. All right. Yeah.
Computer, fix it.
Let's see. Nothing like the bug in life. Yeah, the pod is running, and why not traffic? Yeah. Let's go back to green. I have a preview also here that is also not working. So basically the two services are not reachable for some reason. Let's see. Okay. The canary is not working. Why is this not? Okay, there it is. For some reason. So now this table is the other way around. This table is the blue, the canary is the green, and eventually it's all going to be green if nothing breaks again. And we'll take a look at the analysis. Analysis run. I'll make it a bit bigger.
The bottom is the traffic split?
Yeah, it's the number of requests you're getting blue and green. So now it's all green. So it's all green, and this is a successful analysis. I can go and look at the previous one 2 minutes ago. I can describe the object. And on the analysis run, I have Gemini 2.5 flash analysis. It tells me, basically my instructions are, tell me, look at this, tell me if I should promote it or not, how confident you are, and it gives me some thing. So I'm going to read it here. Confidence 95, promote is true, remediation, no remediation steps are required as the canary deployment appears healthy. No root cause for a failure, the canary deployment is operating as expected. I have a multimodal analysis here because I'm also running Gemma. So I'm running this against Gemini and Gemma. Gemma is running on a GPU inside this Google Kubernetes cluster. And that's not working that well yet, but it's doing both at the same time. So Gemini is telling me the stable pods show green responses, the canary pods show blue responses. As per the instructions that you can also, in the analysis template, you can say give extra instructions. And my instruction is ignore color changes, because sometimes it's like, oh, it's red. Red looks bad. I will roll back. So as per the instructions, color changes have to be ignored, blah, blah, blah. So everything is fine. And I'm going to do now a bad one. And we'll see, hopefully, how this works. So this new version is going to respond with random colors. Yes?
Sorry, can I ask the question, why is your system doesn't show the problems that you actually solve by yourself?
I didn't solve anything. It just started working again. It doesn't solve it. I'll tell you now. So now I'm getting random colors, which is what I wanted. And it's going to do the analysis, and the analysis is already failed, degraded, and it's going to roll it back automatically. This is what Argo does. Now, why the previous thing didn't work? The previous thing was an issue with the routing. It was not an issue with the new pod not working or not working. So there was something in the routing that for some reason failed, and after I deployed again, it started working again. I don't know what happened that didn't happen before, trust me. Other things happened before, but that one, no.
The system analyzes only...
Yeah, the way Argo works is you have old pods, you have new pods, and you can look at anything you want there, but it's not going out to check if your routing is working. It's not going out through the internet or anything like that. It's just old version, new version, and you compare. You cannot. It's not just that you can check the new version, but you can also compare both versions. One thing we are doing is, I don't care. For instance, you could say 500 errors are bad, but if the old version also had 500 errors, what do you do? So what we then doing is, I don't care about 500 errors as long as they are not 5% more than the previous version. You can do these things playing with both versions at the same time. So you saw this thing fail, it was rolled back, the analysis failed. Yes. Now, I'm going here to my repo, and 1 minute ago, my system created an issue. The analysis says the stable pod is consistently serving requests with green responses, healthy, blah, blah, blah. The canary pod is frequently experiencing panic serving runtime error. So it went autonomously, checked the logs, described the pods, whatever, I don't care. So these panics are critical application errors and not merely aesthetic differences. What do I do with this issue? This issue is already very good, right? I can go here and tell somebody, hey, the canary broke. Here is why it broke. But the next step is I tell my AI plugin, when it creates the issue, it labels it with Jules. Jules is a Google bot for code, for writing code. You can use Copilot, you can use, what is the other one, the Claude. Basically, once you have an issue, it's very easy to get one of these coding agents to just work on it. So Jules is on it, and Jules is doing its magic here, and it's going whatever. It has the instructions, it gets the logs, it has the logs, it's working somewhere and it's figuring out what to do, and it is, I think it's already, yeah, it ran the full test suites, test passed, it's done everything, right? And it should, so this was 2 minutes ago. In 2 minutes, I have a PR. And let's go to my pull requests. Well, it's not there yet, but the previous one I can show you. It's going to show up in a bit. And so it created this commit removes the intentional panic. So it figured out I intentionally put it in. Because like, yeah, you're not that dumb, just you intentionally put this thing in there. So, and it just removed the whole thing. Well, it went, if I put it here, if just try to access, create a panic because I'm accessing an index that doesn't exist. And it went like, this is all shit, remove everything, right? So, and it's very cool, like Jules is reporting for duty, and you can talk to it. And then I also have Gemini Code Assist, another bot, to review the PR that Jules wrote. So it's telling me, yes, resolves a critical issue, eliminating a deliberately introduced panic, and clean up the unused imports. So now, if I go back here, is it not yet? Not yet. Okay, so it's still working there somewhere. Yeah. All the steps completed, ready for submission. So in a few minutes, I have a PR to fix my issue. I can just merge it, and this whole process starts again. And, okay, let's see this one. Is it here? There it is, open now. And again, this is, every time you get a different description or whatever, doesn't matter. Removing the intentional panic, index out of range, blah, blah, blah. Well, let's see what changes. Sometimes it makes different changes. This time made the same change as before. And that's it. I don't have to do anything else. So, rolling, just to wrap it up, so rolling out changes to all users at once is risky, as you've seen when bad things happen. Canary rollouts and feature flags, I didn't even went through this, but feature flags, canary rollouts, all these features allow you to do this in a safer way, and you can use AI to automate all these things. So I, for one, welcome our new robot overlords. And you have all the source code, so Argo rollouts, the metric plugin that uses LLMs to do the analysis, and rollouts demo, that's this demo, and the Kubernetes agent, you can write your own agent. But let me also show you I was going to show you when something good happens. I think was it here? So with Gemma, let's see. I have the log here. It goes and tries to run a bunch of tools. So you can see how the LLM thinks. It goes executing tool list pods, executing tool get logs, get events, the back pod, get logs again, get events again, and so on. So you see how it's trying to figure out, because basically I'm not, and you can write more complex prompts and giving it more information. I didn't bother too much, and it just keeps going, okay, I'm gonna check at the logs, check the events, check this, check that, and then it's gonna do it by itself. Okay, so any questions? Yeah. Yes.
How do you think is it ready for the production? Or do you use it in production?
No.
Why? When do you think
I mean, there's nothing preventing you from running this, because the worst thing is going to happen is not going to roll out something. But that's something that is fairly new. I wrote it in September or so. But because I think this is a good way to get it, because then you don't need to take any risk. The worst thing that can happen is that either you promote something that is bad, sure, that would be bad, or roll back something that is good. That's not a big problem. Yeah? Yes.
Question: how you connect? How do you decide what metrics to provide and what metrics to not provide to the system? What do I mean? For example, as I understood, as you told before, you just read the logs of certain pods, but can you read the logs of other elements? And is it possible in this?
Okay, so the question is, how do I define what metrics to provide and what not? With the agentic part, I don't provide that. You can use Argo Rollouts without AI, and you can say, go to Prometheus, get the metrics and whatnot. In your agent, in my example agent, I only do list pods, get events, and so on. But you could have a tool for your LLM that says, get metrics. But then you have to say, okay, get metrics, what it means. It means going to this Prometheus server, and then you can get the metrics, but you would have to define how the LLM can go and fetch your metrics. The LLM will then tell you, I want to call this tool, get metrics, and then your agent is going to do and make those calls and give the results to the LLM. So you could also have metrics embedded into the LLM reasoning.
So which means, for example, when you had problems with routing, actually you could connect more data sources.
You can connect as many data sources as there's no limit other than how the reasoning of the LLM. If you also give too much information to agents, at that point you would go into a multi-agent system where you would have multiple agents collaborating and talking to each other. So maybe you have an agent for metrics, you have an agent for Kubernetes, you have an agent for something else, and they would talk to each other to figure out, to get data from one another. Yeah. Okay, thank you.